ones and zeros. Let's go to a few Goddard visualizations, and up first we have the connection between ENSO, which is El Nino and La Nina, and the precipitation anomalies over Africa, and both of their connections with the outbreaks of Rift Valley fever. The disease has environmental parameters for both the Earth and the humans it's affecting, where the rains not only affect the outbreaks but the spread and ability of humans to deal with the disease. When you look at just the Rift Valley fever atop the moisture anomaly, we see it following rainy periods that arrive abruptly and switch to the drier conditions. You'll be able to see that even better as we zoom in to South Africa, Botswana, and Namibia here. The orange dots are the outbreaks of the disease, and they do follow the major rain events as they peak, crest, and then wane away. Now up next, put on your imagination caps as we zoom into the future at a space weather history museum. Now picture a future tour guide saying to a class, "Long ago and far away, this is how primitive humans looked at the sun's effect on climate, how much light energy comes in, how much is reflected, how much of the intake is held versus released back out into space. Today, of course, we know the particle energy is vastly more important, affecting the global electric circuit and geomagnetic systems for 10 to 1,000 times the climate effect of sunlight alone. Thank goodness the IPCC changed the game long ago in 2022 and let the sun's particles play, or we may be still stuck with carbon taxes." Now, of course, my fantasy aside there, it is 2020. The scientists behind the scenes are preparing for 2022, while the mainstream news continues their one-sided story stuck in the past. If you are brand new here and can't figure out what on earth we're talking about, watch our climate series, and I have to recommend you either begin with the first or the last one on our climate change playlist. It is linked for you below. Interesting news on Betelgeuse, and I doubt there are many out there who want to hear this possibility. Turns out, I'm not the only one who thinks it is possible that it appears to have already had a micronova and the show is already over. The appearance change of Orion's shoulder cannot be accounted for with the standard temperature shifts associated with pre-nova processes. The luminosity profile and even the shape suggest our viewpoint is significantly obscured and perhaps even warped. Of course, the rough aspect of this analysis is the surrounding material that does appear to be a micronova, but which of course is also a part of many nova models when a shell release happens in sequences, often years apart. Now we're going to keep with the nova topic for a minute, looking here at Gemini's latest capture of a remnant 6,500 light-years away. A gorgeous shot of a former star who took the road all the way to the finish line. Long ago, it may have looked like Cygnus A right after it blew. The nova shell here in polar outburst was featured recently in ultra-low frequencies. One of the lowest energy light studies of the heavens is focused on nova remnants and provided some of the first ULF images of these bursts. They are certainly not as eye-popping as the infrared, UV, or X-ray returns in composite color, or the wide radio range spectral recognitions, but these lowest frequencies do a better job capturing the overall density, energy, and emissivity of the remains. Of course, there have to be remains to have a remnant, and we know some nova are very small, recurring, and in some cases, maybe even non-existent. Folks, while we know dwarf nova are in the disks around stars, and type 1 X-ray bursts, which nova barely reaches the disk, both smaller than the recurrent nova we'd expect on our star on the 12,000-year period or so, and today we're looking at what must by definition be the lowest end of the nova scale, a total star ignition, no ejector release, the tiniest micro, dwarf, mini, nano nova you could ever imagine. They indeed come as big and as small as your imagination can handle, and they'll go off at a star anywhere between 1 year, like the one we know of in Andromeda, or have an ultra-long period, again, like we believe our sun has, about 12,000 years. Quick note here, looking into the past, turns out there is evidence of humans arriving and thriving around India about 80,000 years ago, and their survival of the greatest catastrophe of the last 100,000 years. Gothenburg magnetic excursion 12,000 years ago, Lachamp 40,000 years ago. Both were terrible, but neither can match the destruction of Toba 70,000 years ago, where we do have evidence of a magnetic shift as well, and when as little as 40 reproducing females survived. Last but not least, we have a confirmation of that bombshell that Milky Way dwarf satellites don't have dark matter. There is no better way to put